AC. You understand? That is what you have. Now if you are relating your inductor, you understand, in an AC circuit, this is the diagram. You need to understand. Now here now we are looking at inductor. So we are looking at just an inductor in an AC circuit. Now how do you go about that? If you have something like this, here's the source. Now if that is that, then we'll be able to now, this is how to what? Represent an inductor. Are you getting it? Now from there, you now have, you draw something like this. That's your voltage of what? Of that your AC source. So if that's voltage of your AC source, then we have your I of L, not voltage of L. What does L mean? Inductor. You understand? This is the region where your inductor is located. Now, mind you, this is your voltage of your alternating current. You discover that by the time current and voltage flows out of this device, you discover that your current lags behind. Something like this. It lags behind in the circuit, whereby the voltage comes this way and goes that way. So at this junction now, here is your V, that's your voltage, and here is your what? I. Where you're supposed to have your resistor, you replace it by what? A pure inductor. So all these diagrams are actually explanation of you linking your inductor straight with the source, linking your resistor straight with the source. What do you have? What are the graphs you have? If you are being asked for this in WAEC or your any exam which you are actually applying for, if eventually you discover a question like this, you first draw the diagram, you give the explanation that okay, at this video we are looking at a purely inductive circuit. Now this is the inductor. Now you are linking the inductor with your what? The source. Now from there, what type of graph do you have? You have a graph whereby the current lags behind. In this case now, your voltage is what? Is ahead. You understand? Is ahead of your current in this type of the circuit. The voltage that will be formed will be ahead of your current. Mind you, your voltage, your actual voltage, instantaneous voltage is V0 sine omega t, inclusive of your what? I. So you also include this equation with what you are presenting to your examiner. He or she will understand that okay, you are trying to draw a purely inductive circuit. So that's for your inductor. Now let's proceed as regards the graph. The graph that will be what? Obtained. You understand? Graphs that will be what? Obtained. Now if we look at it properly, we said the current lags behind. So the voltage is ahead. So you can now say that voltage is 90 degrees ahead of what? Current. You understand? In what? In a purely inductive circuit. We'll be looking at the LR, RC, then the LI, LR, LRC circuit. You understand? We're looking at three different circuits now. Now, if you are looking at the three, you have something like this: your resistor, your inductor, and your capacitor attached with one voltage in between. You understand? Now, the voltage here will be VR, the voltage here will be VL, the voltage here will be VC. This is R, this is L, and this is C. Are you seeing it? Now, we have your, this is an alternative, not indirect. So you have your VAC here. Now, let's now start with the first one, LR circuit. So in your LR circuit, what do you have? You have something like this. Your resistor. Are you seeing it? Your resistor, your inductor. You understand? Then the what? Alternating. You understand? Now at this region now, there's what we call reactance. Now at this region, what do? You have to obtain the Z. You understand? That you obtain, there's what we call reactance of your what? What you have here is Z of what? RL will give you square root. Are you getting it? Square root of your what? Reactance of your inductor plus reactance of what? So we have our tank inverse our tank inverse, our phi will be given as tank inverse of your reactance of what? An inductor over your R. What am I trying to say? Here now, we are looking at resistance and what? L. Do you understand? If you are looking at resistance and L, you have to get your reactance of your what? Your inductor and your resistance. You understand? The reactance of the inductor and the resistance will make you get your what? Impedance Z. Do you understand? The impedance Z is actually what? The resultant of what? Of the two what? Resistance and what? Your inductor. Those are the parameters you use for your calculations here. Now your RC, you have a circuit like this, capacitor, then your what? Are we getting it? Now from there you have your what? Your reactance. The impedance will now be impedance of RC will give you the square root of the reactance of the capacitor, right? Then your what? R squared is radius and capacitor. You have your voltage of what? Resistance and voltage of what? Capacitor. Are we getting it now? So from here, you now be able to have your phi to be tan inverse of your what? Reactance of what? Capacitor all over what? Your resistance. That's the third one. Now if you proceed to the next one, is the second one. Proceed to the last one, you have your what? Your capacitance to L circuit. For your capacitance to L circuit, what do you have? You have your what? Impedance of LC will give you square root of reactance of your inductor plus reactance of what? Capacitor. Are we getting it now? So if you check, sorry, there's an error here. So you have what we call reactance of inductor minus reactance of what? Capacitor. So at this junction now, you'll be able to now get the what? Angle. The angular difference, that will be your what? Over, to just be over reactance of what? Inductor over reactance of what? Capacitor. That's just all. So for all these are the values we'll be making use of by the time we start the calculations now. Now at this junction, I also want to remind you that when you are actually calculating, you must also note one fact. There is a formula for reactance for what? Inductor. Your reactance for inductor, is given as what? Your omega M. How do you get your omega? Your omega is always given as 2 pi F. So you just say your 2 pi F is your reactance of inductor. That's if you want to solve separately. Now for your reactance of the capacitor, it's given as 1 over omega C. And that will be 1 over 2 pi F C. That's your reactance of what? Capacitor. So these are the two formulas that we'll be making good use of. We hope we are getting it. These are the formulas we're making use of. That's your 2 pi F, where your F is your frequency, this is your inductor, and this, of course, you know your pi. You also know your pi here. This is frequency, and this is your what? Capacitor. It's very easy. When you are given this, you can calculate for this. You are given this inductor frequency, you can also what? Calculate for this, so that you'll be able to obtain the impedances. So at this region now, only two other factors need to be known. You must now also know what we call resonance. You can be asked to obtain your resonance. For you to obtain resonance frequency, you just say your frequency will become 1 over 2 pi root LC. Your inductance multiplied by your capacitance, the square root multiplied by your 2 pi. Find the one, you understand, the reciprocal of it. You'll be able to obtain the resonance frequency. That's just all as regards your alternate current circuit. We are going to start the calculations now, just one or two. Then we'll go back to our transformer, we'll deal with that, then we'll be able to trash things out. Number one says, calculate the peak voltage. Calculate the peak voltage of a main supply of 240 RMS volts. I'm not going to run this on. So if we can have 240 RMS volts. Are we seeing it? Now remember, we said your VRMS is same thing as V0 over root 2. This is the peak voltage you are looking for. So if this is VRMS, if you substitute this in, you're able to have 240 RMS equals V0 all over root 2. So your V0 equals root 2 times 240. That's the value for your peak voltage. That's for the first question. Are we seeing it? For the second question, in a series L to C, that's the second question. Series L to C. This is series R to C. This is series L to C. Now in an L to C circuit, this is series L to C circuit. This is the impedance. Three things you need to know. The impedance of RC, this is the formula. The impedance of LC, this is the formula. You don't need the square root. Now the impedance of the third one, which are written initially, and you just get it. Let's find it now for the number 2. Listen, RLC. So you say, you just say solution. You must know the kind of capacitor you are dealing with. This is LC, where you have your inductor, your capacitor, then your alternating current. You draw your graph for your examiner for him to understand, you know what you are doing. Now you are given the capacitance of 5 coulomb, right? I'm giving the capacitance of 5 coulomb. Now you are also given an inductor. Sorry, the inductor is 5 Hz. Now the capacitor is 5 microfarad. Are we seeing it? The expression. Now we are told to calculate resonance frequency.